Okay. So we have talked about
A lot.
parallelism, which is instruction level parallelism, which we talked about. I'm sorry, pipelining, which is instruction level parallelism. We talked about that a couple classes ago. We talked about coarse grain threading, coarse grain multi-threading, fine grain multi-threading, SMT, which is a way of doing multiple threads on top of one core. We talked about then we talked about SIMD, which was special instructions to operate on multiple pieces of data. Then we talked about GPUs, which were a way to execute a ton of SIMD instructions at the same time. Now we're going to talk about what if you just have separate processors all together, aka processor, cache, memory, interconnect network, memory, cache, processor. Here's a good example. Just replace interconnect network with the internet, and these are individual cache or computers.
Okay.
Okay?
Okay.
Now, in general, if you want this high performance, you're going to have your own LAN right here. But notice that each computer has its cache and its own memory. Beforehand, we were sharing a piece of memory. Now each processor has its own memory. So each processor has its private physical address space, and the hardware is going to send and receive messages between the processors. All right. Oh, have y'all used this before?
Sure.
Sure. Anyone have a good example? Do you still have SETI at home working?
What?
Sentient.
SETI, S-E-T-I? Search for extraterrestrial.
Like that's that thing where it's like you can like outsource some of your computer processing to help search for aliens.
Yeah, that's it.
Crap.
What?
Yeah.
Y'all haven't seen this?
No.
I don't have it on my computer, but I know of it.
Why? Oh, people are weird.
That was. If that's news to you, you're in trouble. Let's see what comes up.
Did you just open Firefox from command line?
Yes. What? What else would I do?
I've never done
Search for extra is a collaborative effort. All right, where's the wiki?
Where's the wiki?
Oh, all the way down there.
Yeah, it would do this cool little graphics for you as I was trying to find different things. No one ran this?
No.
Wow.
Did you run that?
Yeah, just for like 5 minutes.
They downloaded all your information. The aliens did.
Back in the late 90s? Sure, whatever.
Yep.
All right, well, that's good. They can have
This
it.
is a massive ploy by aliens. To
I wasn't
try and
even
get all of the
an
information.
adult yet officially. Sure, okay, fine, whatever. All right, well, that's not nice. Anyways, well, they've got to have something like this. You can donate your processing cycles for something else, right? They've got to have.
Yeah.
What's the latest craze, guys? Come on, man. Keep me up to date.
Bitcoin. Not well, I mean.
Yeah, that's actually a good example. You're right.
Yeah.
So Bitcoin, because you want to verify blockchains, and then you get your own
Exactly.
little Bitcoins for doing it.
Yeah.
You can't buy a graphics card right now, and probably won't ever be able to again because of the currency miners. So.
Yeah, and I was about ready to buy a new computer. Oh well for that.
I need a new computer. Eventually.
Okay, so we have some examples. Bitcoin.
Some examples. Gives one example.
I did SETI as well.
Alien.
All right, loosely coupled clusters. They're loosely coupled because they're just communicating via messages. They're not sharing main memory or something. They're really just talking to one another. Suitable for applications, independent tasks. Hey, look, here's some more examples. Web servers, databases, simulations. You want it to be high availability. Do y'all know what that means? You want it to be up and running most of the time.
Okay. Not turned on.
Hey, that's what our ethics paper is about.
Yeah, wait.
Scalable. If you need more capacity, you want to be able to just add more hardware and be able to have more capacity. And affordable. People don't like spending money. Problem. Administration. Yeah, you prefer a virtual machine in general, but you have all these machines running around trying to sync it. And are you really going to trust someone else who's on the internet?
Nope.
Low interconnect bandwidth. The internet is very slow as opposed to the bandwidth between your processor and your memory.
Yeah.
All right, let's do 100,000, the sum of 100,000 on 100 processors again. Why not? So again, each computer does the partial sums. So now you're really going to do the same thing, except for, wow, there's no picture? Oh, you are lame. Okay, you do the exact same thing, but you're doing send and receive from the different processors. Okay, thanks slides. I'm going to talk more about that when I discuss MPI, which will be next week on Monday. Hey, look, I wasn't lying. SETI at home.
Hey.
Grid computing. All right, so message passing is usually done on the LAN. Grid computing is done via the internet. You really just want to make use of idle PCs that are in the world. Okay, thanks slides. All right, anyways, let's go into one last thing with our topologies.
I love the fact that you thank the slides.